Hello everybody, this is Scott from Octava Engineering, and this video is just going to be a brief software overview, just to give you an idea of how the software works, the different modules, and best practices for using some of the different features here. So we're going to start out actually by closing the software because there is a new feature that is very important. And that is the Linea's Self-Diagnostic Check. So whenever you close the software, you're going to see this pop-up message here advising you to remove the connection from CN1 or make sure that there's just no encoder plugged into anything, like if you're going through a cable mate or something like that. Because as soon as you click this close button, the Linea is actually going to do a self-diagnostic check. It is going to test all the different power output options that come from this CN1 port here right below the power switch of the Linea. So this is the check to see if any fuses got accidentally opened from a previous test or something like that. But because it is outputting various power levels through that CN1 connection, if you do have something plugged into it, you can accidentally blow a fuse while it does the self-diagnostic check. So those fuses are in place not only to protect the Linea from damage, like if something gets shorted or something like that, but also to protect your encoder. So for example, if you accidentally select a setting that puts out a voltage higher than what your encoder is rated for, that will also blow a fuse. And the fuses are fairly easy to replace, but we just want to avoid you having to do that at all if you don't have to. After the self-diagnostic check, if a fuse is open, a pop-up window will show when you go to restart the software, telling you which fuse is open. And at that point, you can reach out to us at support@octavaengineering.com, and we can give you very clear instructions on how to replace the fuse. Some replacement fuses should have been sent out along with your Linea, just in the event that that ever happens. All right, so the software is now open and running normally. Obviously, or maybe not obviously, the AutoCUE software only will open if the Linea is connected to the PC with both USB cables through a powered USB hub or docking station. So please make sure you're using the powered USB hub if you're not already. That can solve a lot of connection issues. But once the software is open, it defaults to the home screen, which is the minutes screen. And just to point out, this center section here where it says total minutes available are the total minutes available on your online account at octavaengineering.com. And then over here on the actual device, these are the number of minutes on my Linea X3 itself. So when you're using test minutes, you don't have to be connected to the internet per se to use the test minutes, as long as you have minutes on the device. And if you need to transfer more from your online account to the device, you just use this Get More feature here. And click Checkout. And it'll move those minutes from the online account to the Linea itself. So the only time the Linea has to be connected to the internet when you're using test minutes is if you need to move more minutes to the actual device or if you need to perform a software update, something like that. Some other things I want to point out right here on the home screen is the information displayed on the footer here. So this tells you the current software version that you're running. This tells you if test minutes are being used or not. If test minutes are in use, this green bar here will be lit up, and then the minutes used is being accrued right there. This hyperlink icon is actually a newer feature that is very important. If you click on this hyperlink icon, there's an option here for remote connect. So if you're having issues with anything, if you need help, and you want us to remote in to provide support in real time, which is something we're always happy to do, you would click this remote connect to launch a website and an app to allow us remote access. There's a direct link to email support. So if you have a question, that will open up your email service if you have it set up on your Linea PC. So you don't have to open it up and manually type in the address. This is a link to our test cables, which just goes to the Octava Engineering website and our test cables page, where you can sort and filter to try and see what test cables you need, depending on what you're working with. And if you know what test cable you need, but you would rather build it or modify an existing one instead of purchasing one, this link gives you access to our cable build sheets, which is a huge resource. So instead of the long web address being sent to you individually, you can just open that hyperlink and then click it right there. That is a link to our YouTube channel for our ever-expanding how-to video library, link to the accounts page, and a link to the software update. So the biggest ones, probably the videos, the build sheets, the test cables, and the remote connect, as well as emailing support. So those resources are for you right there under the hyperlink. To the right of that, this will tell you what module you're working in. So right now we're on the home screen, the minutes module. And then these three little icons right here are just telling us that we're connected to the internet, and both of our processing devices inside of the Linea are connected to the software. So you can see, for example, if I disconnect the blue cable, we get this pop-up, and then that channel goes yellow, as in bad connection. So let me reconnect it here. If I disconnect the black cable, the software will crash, so you won't even get to see that go yellow. So that's a quick overview of the minute screen. Over here on the left is our main menu. Under Encoder, we have our analytics module, which is what we use to perform analytics on various encoders and feedback devices. If the encoder has memory, under Encoder is our memory module. So if you need to save, write, or set memory to a new encoder, you would do that through encoder and memory. And you can see we have Intermat, SICK Hyperface, and Hyperface DSL, as well as Heidenhain. Under the motor tab, we have our lock-in module, which you would use in conjunction with the alignmate to perform a rotor lock-in and set the alignment. And then just real quick, I'll show you how that works. So with the motor power cable plugged into the alignmate, and clicking the alignment toggle here, that tells you what the lock-in sequence must be to lock the rotor into position to set your alignment. You can use these toggles to lock the rotor into position. So in this case, we're applying positive DC voltage to the V phase and negative DC voltage to the W phase. You just have to click those toggles. Also in motor are our three run modules. We have the free run mode, which doesn't do any analytics on the encoder, just simply runs the motor. The evaluation mode, which is used for diagnosing incoming encoder condition. The biggest thing is that depending on your drop-down settings here at the top, it will check the alignment on an incoming basis to tell you what the expected value was versus what it's finding as it checks those lock-in angles without giving you a pass-fail. So if you want to see what the alignment is without it failing a commutation test like it will in the final test module, that's what you can use evaluation for. And then we have our final test module, which is the module you would use once the motor has been rebuilt and the encoder has been reinstalled onto that motor. Below the motor tab is our more or options button, and there's a lot of different things going on in here. The Intermat and SICK file converter buttons allows you to add files or add folders of files that are in a .hex format from another test system to convert those memory files over to a format that the AutoCUE software can read. So if you're a new user, but you have a whole lot of, let's say, memory files saved from previous systems and just, from years of collecting, you don't have to start from scratch. You can convert those files over to AutoCUE files. The report viewer button here is simply to go back and view previously generated reports. Our reports can be saved as PDF, but if it's an analytics or a final test report, it's automatically saved into the system as soon as you generate it anyway. So you can use the report viewer to go back and view any previously run report. Just like that. And then our preferences button is what houses the default folder path if you wanted to change it. The idle timeout time, which I'm actually going to adjust a little bit. The idle timeout time is a safety feature to prevent you from wasting test minutes. So if you accidentally walk away from the software or walk away from the computer, get pulled away, something like that, while collection is running and your test minutes are being used, if there's no movement detected from the PC, like no mouse movement, anything like that, the software will automatically shut off collection after that idle timeout time has elapsed. So make sure you set that to whatever you're comfortable with. Down here is our IP and network settings, along with the serial number of the device. Aside from initially setting up the Runwell IP and the Runwell Plus IP or dummy IP if you don't have the Runwell Plus yet, you shouldn't have to mess with these settings. The only time you might have to go in and adjust those is if we're having software connection problems, at which point you would reach out to us and we would help you solve that in real time and adjust the settings as needed. Over here, we have some basic analytics settings, which I recommend not changing unless you really need to, including ignoring deflection check for those serial encoders that also have analog signals, and your default resolver parameters. When it comes to resolver parameters and excitation on the reference channel, we find that 6 volts peak to peak and 5 kHz work pretty solidly for most different resolvers, regardless of what their rating is. So unless it's a unique situation, you should not have to change the default resolver parameters. You can also change those on the fly when testing a resolver, as you may have noticed when I was showing you the lock-in screen just a moment ago. Under the Add Motors tab is where you can add new resolver motors, new motors running Heidenhain NDAT, new motors running incremental, either digital or analog incremental encoders, and new motors running SICK hyperface encoders. So if for some reason it is a motor model that is not in the drop-down parameters at the top, if it's running one of those 4, you can add it to the system with some basic information, like knowing what the lock-in is, if there's an offset, things like that. We're going to do more in-depth videos on how to add motors and what you need to do in order to add those, but this is just an overview. The Run Well tab, there is an option to stop the run test at error. So if you're running a final test and the system detects a critical fault from the encoder, having this checked will stop the test as soon as that critical fault is observed. Most of the time I would recommend leaving this unchecked, just because you want to be able to see that report. And if there is a critical fault, you want to be able to see it on the report so you can try to figure out what's going on there. So that was the Preferences button inside of the More tab. Below that, we have our Reports button, where once you're in Analytics and you have collected enough data to generate a report on the feedback type that you're working with, you would click the Reports button. In this case, because I haven't done any testing, I'm going to get that pop-up error saying data missing. And then this button here is just a screenshot button. So if something's happening the way you're not expecting, or in certain instances, it'll even show a pop-up saying, you know, please lock the motor into this position and send a screenshot to us. That is for unknown alignment issues with certain feedback types. That button there is just a screenshot, just so you don't have to, you know, hit, you know, Windows print screen. It does it right there for you and saves it to the file path specified. The only other thing I'll mention before we go are our drop downs here. So our system is not driven by motor manufacturer or motor type. It is all based on the feedback type. So we have serial encoders, which is any encoder, even if it does have analog signals, that have some kind of serial data being transmitted. And then manufacturer is the manufacturer of the encoder, not necessarily the motor manufacturer, although sometimes it will match, like Fanuc, Yaskawa, etc. And then the type model of the encoder. And then the number of pole pairs of the motor. So these drop-downs will change a little bit under serial depending on what you're working with. So like for SICK, it's going to ask for the communication interface, hyperface or hyperface DSL. For Intermat Rexroth, it's going to be auto-identified by default. If you're familiar with Intermat at all, especially MHDs and MDDs, most of those do use Heidenhain encoders, but there's a special I2C protocol in them that is unique to Intermat, so we separate those from Heidenhain in the dropdowns. Some of these feedback types are going to be purely serial. They only have a data and a data not channel. Other of these serial encoders are going to have that serial communication, data and data not, but they will also have analog signals. But just keep in mind, if there's any type of serial communication, you know, any kind of computer jargon communication going back and forth on an encoder, it's going to be considered a serial encoder. Below serial, we have resolvers. And the physics of a resolver is always pretty much the same, regardless of, you know, the ratings, the number of pole pairs, or in terms of resolver speed, I suppose. But number of pole pairs, again, of the motor, not of the resolver. And then selecting the manufacturer will just denote what the lock-in should be based on the motor manufacturer, the partial model, and the number of pole pairs. And for resolver, there's also generic options here. So generic, low output generic, and then multi-speed generics, 2-speed, 3-speed, 4-speed. Again, this is an example you can also add to that list, but that's for another video. Then we have incremental encoders. Whether it's digital or analog, incremental encoders are encoders that do not have any type of serial communication. And then you have the encoder manufacturer, and then type model, and again, enter the number of pole pairs in there. One word of caution about incrementals. HTL encoders. HTL stands for high threshold logic. Those are usually used in larger applications, sometimes spindle motors, sometimes even certain induction motors, but HTL incremental encoders have a much higher input voltage than regular TTL encoders. So just be very sure if you're selecting an HTL dropdown that you know for a fact that the encoder you're working with is HTL, because it's going to use 12 volts for the power supply instead of 5 that a TTL would use. And then we have Hall sensors for Mac motors, Siemens HT series. Just like that. So that is a quick overview of the software. You have file close. You can click about. That'll just bring you to our website. That is a 1,000-foot view. The other videos that we have are going to do the different encoder types more in depth, along with how to add various different encoder types. But this is just an overview of the software. So that's it. Thank you very much.